Hello friends, in this video we are going to continue the second lecture of logarithm. Here we discuss basically the properties of log. Now here we consider that wherever the log is defined, in that cases only the property is defined, that I am going to discuss. So wherever log is defined, here we assume that wherever log is defined, wherever it is defined, in that cases our property holds. We need not to write separately all the conditions again. So now property 1 part 1, log of n base is also n. So we know that n raised to the power 1 is n, so answer is 1. Log 1 by n raised to the power n is minus 1, because we know that if we raise the power of base n as minus 1, we will get the 1 by n. Third one, log n and its base is 1 by n. So 1 by n when raised to the power minus 1, it will be n. So answer is minus 1. 4, log of 1 base n is 0. 5, log n base a, it is positive. Log n base a, it is positive when n and a are on the same side of 1. Same side of 1. Suppose 1 is here, from here 0 and here is up to infinity. So when n and a both lying in this interval, or they are lying in this interval, so then log will be positive. Either both n and a lies on left side of 1 or right side of 1. For example, if you are taking log of, suppose base you are taking half and here 1 by 3, so this value is always positive because both lying on the left hand side of 1. If you are taking log of something 11 and here you are taking 100, so now both the number is after 1, right side of 1, so it also gives you the positive value. But if it is reverse or opposite, that means I want to say log n base a, this value is negative when n and a are on opposite side of 1. So if it is 1, here 0, infinity, so if your 1 n is here, then a should be here, or a is here, n will be here. So in that case the value of logarithm is negative. Example, you can take log of half. So log of half, the number is left on 1 but 10 is right on 1, so answer will be negative. Or you are taking log of 5 and your base 5 is right side of 1 and base you are taking 1 by 3, you are getting negative. Okay. So log is positive and negative depending on the values where it lies in and a. Okay. Now coming to the next property, property number 2. This is known as fundamental logarithmic identity. Fundamental logarithmic identity. So if you have a and to the power log n base a, it is always n. Why? Because why it is happened? We know that n is equal to a power x. From here we get log n base a is equal to x. Now put these values of x in the 1. Put the values of x log n base a here, you are getting these results. Okay, now this naturally happens. For example, if you have 3 and here it is log 3, suppose the number is 5, so you can directly write it is 5. You can directly write it is 5. Is it okay? Now property 3, log m and n in the product form you can write as log of m plus log of n, but here base should be the same. Suppose if you have log of 2 base 6, log of 3 base 6, so you can write log of 2 times of 3 base 6, which is equal to log 6 base 6. Both are same, value is 1. Is it clear? We generally don't know what is the value of log 2 base 6 without table, but using the property, when you merge these two, you will get the answer. Okay, now this property you can extend. Suppose if it is m, n and p with base a, so you can write as log of m base a, log of n base a, log of p and base a. Okay. Now next property number 4, log m by n you can write as log of m minus log of n. Basis is same a, base is same a. Okay, now suppose you are going to calculate log 80 base 5. So without table we don't know, log 16 base 5 we don't know, but when we use this property we have 80 by 16 base 5, which is equal to log 5 base 5, and that is 1, and that is 1. Okay. Now next property, if you have log suppose here log x and its power is m, here it is a, so we can write m, this m will be outside of log. We can take this m outside from the log, so it will be m times of log of x base a, m times of log x base a. Suppose we want to calculate these values. Suppose log 3 is here and here 1728 and here 12. So what is its value? We can easily write 12q, and 1728 you also know that 12q, so this will be 1. Both the number is same, that's why it is 1. Coming to the property 6, this is important, one of the very important property, that is known as the base changing theorem. Base changing theorem. Log a base b is same as log of a base c divided by log of b base c. Okay now here you notice that when you write the log in the form of quotient, it is independent of the base. It is independent of the base. Okay. So now we do one thing. From here one corollary we can write. Achha, suppose what is the use of this property? Suppose you are going to calculate log 1024 and base is 64. So now here it is difficult to find out its value. You can do one thing. You can write log of 1024 and here you can write log of 64. So we can put one base by which we can write that base to the power something will be 1024. So I am taking here 2, here 2. So all of you know that here answer will be what? 2 to the power what is 64? 2 to the power 6 is 64 and here 2 to the power 10 is 1024. So answer is 5 by 3. So this is the use of this property. Very nice property and important property. We can use many sums on the base of this. Now what will happen to this one? Log of, if you have suppose a base b, so again as a corollary you can write this property. So here we know that it is independent of base, so it is log a and then it is log b. So if I put here same base a and a, so by the definition log a base a is 1 and it will be log of b base a. So log of a base b is same as 1 by log b base a. That means if you want to write log 5 base 3, you can write as 1 by log 3 base 5, log 3 base 5. Now we can find this value, or we can take it as an example of this problem. Log of a base b multiply with log b base a. As you know that both are reciprocal, or by using the base change formula, first one is log b by log a, second one is log a by log b. So they are cancelling and the answer is 1. If you want to extend this one, you can write log a base b, then log b base c, then log c base d, and then log d base e is equal to what? So here you notice that log a base b and b cancel, c cancel, d cancel. So remaining is a and e, log a base e. Log a base e we can write. Okay now. So when you cancelling, don't show on the paper, just mentally you can cancel out. Just mentally you can cancel out. Is it okay? Property 6. Now coming to the next property, property 7. Log a and b has the power n. So now by using the base change formula, we can write as log a and here we can write log of b power n. Any base you can put here. If I put here c, no problem. So it will be log of a base c, and here by using the property log of n log b base c. So this will be what? 1 by n log of a base b. 1 by n log a base b. Okay now, so when the power you get the power in the base, this power will be outside and it will be in the position of denominator. It will occupy the position of denominator. So if we combine these two formula, so we are getting this one, log a and b. Here power is m, here power is n. So we get a fraction whose numerator is m, denominator is n, and it is log of a base b. So just we are doing one example. That example we are doing with the help of this property 1024, and it is 64. So we can write as 2 to the power 10, and it is 2 to the power 6. So it will be 10 by 6 log of 2 base 2, which is 1, and here you are getting 5 by 3. Here you are getting 5 by 3. Okay, now try to solve one more property. We have one more property, property number it is what, 6. Acha, this number will be 7. So we have property 8, it is property 7. Next we have property 8. Property 8 says that if you have a to the power log x base b, so you can write as x whole to the power log a base b. That means you can interchange this a and this x. These two you can interchange. This is also important. This property is also important property. Okay now. So now we are going to solve few questions on the basis of this theoretical part. Okay now. So these questions are conceptual questions, not very tough. Question number 1, log 40 base 2 minus log of 625 and base is 16. So what is its value? So now these things we can write in this way, log 40 base 2, and here this thing I can write log 5 base 4 and 4 to the power 4, not 4 to the power 4, 2 to the power 4. So this is same as log of 40 base 2 and log 5 base 2. So this will be actually log m minus log n we can apply to 40 by 5 and base is 2. So log is 40 by 5 8 base 2, that is log 2 power 3 base 2, that is we can write 3 times of log 2 base 2, that is answer is 3. Now try to solve question number 2. 1 by log 2 base 3 plus 2 by log 4 base 9, 3 by log 8, and here 27 in this way. Last value is 10 by log 2 to the power 10 and 3 to the power 10 minus 55 log 2 to the power 55 and minus 3 to the power 55. This value we want to calculate. So you notice that log 4 base 9 is same as log 2 base 3, log 8 base 27 is same as log 2 base 3. So therefore what we do, we can take this number outside, log of 2 base 3 from the denominator. In numerator we have 1 plus 2 plus 3 in this way, and these values goes to what, up to 10 minus 55 by log 2 to the power, अच्छा log 2 to the power 55 by 3 to the power 55 is same as log 2 base 5, log 2 base 5. So here 1 by log 2 base 3, sorry 2 base 3. So you know that the sum of the natural number from 1 to 10 is 55. So this will be 55. So what we see that both the term are same, opposite in sign. It is 0. Okay. Now coming to the next question, question number 3. 5 power log 7 base 3 plus 7 to the power log 3 base 5 minus 7 to the power log 5 base 3 and minus 3 to the power log 7 base 5. What is its value? So first of all we find out, we should interchange these two one. Okay, now so what we have, 7 to the power log 5 base 3. Next we change these two value, interchange by the property. So we have 3 to the power log 7 base 5. Remaining value as it is, 7 to the power log 5 base 3 minus 3 to the power log 7 base 5. So these and these cancel out, these and these two cancel out, which is equal to 0. Hope all of you understand this question. Now we are going to solve another question. Question number 4. Let A is given as log of 11 to the power 1331 base 11. Okay, now so B value log of 1 base 6, log of 2 base 6, log of 3 base 6. C value log of 4 base 4, log 2 and 5 to 625. D value 5 to the power log 16 base 25. So they are asking what is the ratio of AB and CD. ABCD ratio we want to calculate. So you know that anything will be power of the argument we can take outside. So this is, we can take outside of the log. So it will be log 1331 11. Log 11 base 11 is 1, and here 11 to the power 3, 11 cube is 1331. So answer is 3. Here if you apply the property of log, you are getting 6 base 6, which is 1. Here you have this value is 5 power 4. So this 4 you can take here. So 4, this 4 you can write as again 2 square. This 2 you can take here. So ultimately you have log of 2 base 4, which is equal to log 2, and 4 you can write as 2 square. So 1 by 2 log 2 base 2. Achha, now here this value which is, I think this value is 16. So 16, 5 to the power 16 means 2 to the power, or you can write as 4 to the power 2, and here 5 to the power 2. So it will be 5 to the power log 4 base 5. So answer is 4. So what is the value of AB? 3 into 1 3 and 4 into half 2. So 3 is to 2 is the answer. 3 is to 2 is the answer. Question number 5. if log 2 base 3 log 3 base 4 log 4 base 5 in this way log of n base n plus 1 is 1 by 10, then find n. So here we do one thing, cancel out this. So this n also cancel out with n of another just preceding term. So what we have, log of 2 and here n plus 1, which is equal to 1 by 10. Use the property of logarithm, interchange this value n plus 1 by 2, which is equal to 10 by 1. So from here we get n plus 1 is nothing but 2 to the power 10. So n is equal to 2 to the power 10 minus 1. This will be the answer, or 1023. Next question number 6. Let a is equal to 2 power log 3 base 2, b is equal to 3 power root of log 2 base 3. So now find the value of a minus b. What we do here, a is equal to 2 to the power log 3 base 2 and b is equal to 3 to the power log 2 base 3. Here we can do the rationalizations. So it will be log of 3 base 2 into 1 by root over log 3 base 2. I just done here the rationalization, multiplying with a root of same number log 3 base 2 numerator and denominator. So this number according to the property, these whole things according to the property we can write 3 and its power is 1 by root over of log 3 base 2. So this will be what, 3 to the power, now you can write as log 2 base 3 and its whole root, which is nothing but b. So what we know that a and b are same, so a minus b will be 0. This will be the answer. Now going to do last problem of this concept, that is properties of logarithm. Now here log 12 base 3 log 3 base 36 minus log 4 base 3 by log 3 and here 108. So now how to solve it? It is log 12 base 3 multiply with log 36 base 3 minus log 4 base 3 into, here you notice that all the logarithm have the same base 3. Okay, na? So in this type of problem what we have to do, we do the factorizations of the argument. So these things I can write as log of 4 into 3 base 3. I want to write all logarithmic in terms of 4 base 3. 4 into 9 base 3. It is also 4 base 3. Now these things log of 3 and here we can write 4 into in this way. So log 4 base 3, log 4 base 3 plus log 3 base 3 1. Here log 4 base 3 and log 9 base 3 is 2. Here log 4 base 3 is okay. Log of 4 base 3 plus log 27 base 3, that is actually 3. So now we do one thing here in this step. Put log 4 base 3 as t. So this number will be t plus 1, then t plus 2, then minus t plus 3. So it will be t square plus 3t plus 2, and here t square minus 3t. So what we have after simplification 2. So technique is, sometimes when the bases are same, in case of logarithm, so we have to do the factorization of argument and try to express all the logarithm with the same input and base, same input and the given base, so that after cancellation you will get some answer. So in this session we discussed about the logarithm and its property. In the next class we will do something more about the logarithm, some interesting fact or properties of logarithm. Okay, now till then, bye, have a nice day.